Welcome to the notes for Pre-Calculus Essential Skill E3, Coordinate Trig. We're going to redefine our trig functions one more time so that we can apply trig anywhere in the xy plane. So now we're going to start with an angle in standard position. So we're centered at the origin. The initial side is now along the positive x-axis. And we'll have the terminal side pass through a point P, some point on the terminal side. We're going to let R be the distance from the origin to point P. Next, we'll drop a perpendicular from P to the x-axis. And we've written in the distance R. We have a right triangle whose sides are now the x-coordinate of point P, the y-coordinate of point P, and R, the distance to point P. We'll label the angle theta, so we have a reference point. We're going to model this definition after SOHCAHTOA. It's not precisely SOHCAHTOA because we're not always going to have a proper triangle, but it'll still be used as the inspiration. So the side opposite of theta is y, adjacent to theta is x, and the hypotenuse will be r. Our new definition is that sine of theta is going to be y over r. This has similarities to SOHCAHTOA in that y was opposite, r was hypotenuse. This also has similarities to the unit circle, where the sine of theta was just the y-coordinate. Similarly, we'll let cosine of theta equal x over r. And this we borrow from the last notes. Tangent of theta is going to be y over x. It's like opposite over adjacent. From here, it's pretty easy to derive the reciprocal functions. We have cosecant of theta is going to be the reciprocal of sine, r over y. We just flip it. I don't necessarily expect you to learn the reciprocal function definitions because once you know the primary three trig functions, you can get them very easily. Typically in a situation like this, you'll be given the xy coordinates and you won't know r. Well, how do we find r? Well, it's a right triangle. We can think of this as Pythagorean theorem, or we can think of it as distance formula. Either way, we end up with x squared plus y squared equals r squared. All trig functions of theta are completely determined by x, y, and r. Here's a sample problem. I give you a point that the terminal side of an angle passes through, and then you find the trig functions. It's very important always to start with a sketch. So we're going to, it can be a very rough sketch. We're going to draw some axes. And let's call this -4, let's call this 3. So here is our point P on the terminal side. So here's our initial side, our terminal side, and now we draw a perpendicular to the x-axis. This is a length of 3, this is a length of 4, but this is going to give us our right triangle, so we can find r. It's important to note that while x and y are coordinates and they can be negative, r is a distance. R is always positive. So we're going to take the positive root of 25, so 5. It's very handy at this point to write down your x, your y, and your r collected in one place. Y is 3, x is negative 4. And now, when we find the trig functions, we can refer to this block. So sine of theta is going to be y over r, and so we just plug in 3 over 5. Cosine of theta is going to be x over r. That's just, remember that x is negative 4. That'll be negative 4/5. And tangent of theta is going to be y over x, which will be negative 3/4. Similarly, the reciprocal functions will just be the reciprocals. It's very important to draw this sketch because the most common error is to omit the sign or to get the pluses and minuses wrong. That happens a lot less frequently if you draw the sketch and you recognize which quadrant your point is in. Here's an example for you to try. Pause the video, give it a try, and then I'll give you my solution. Here's my solution. Notice we always connect to the x-axis. Notice that finding the reciprocal functions is much easier if you choose to flip the unrationalized version of sine and cosine. And we're done. Another type of problem you might see is when I give you one of the trig functions, and all I tell you about the terminal side is that it's somewhere in one of the quadrants. We'll use those clues to piece together the rest of it. It is even more important to draw a sketch in this case because of the quadrants. We will be backtracking and finding coordinates. Coordinates may be positive or negative, and so a sketch will show you exactly which sign to use. We'll start with what we know. Cosine is x over r, and so if we want to plot this, we can use x equals 5, r equals 13. We don't know that x and r always have those values, but they will be in that proportion, and so this is these are as good a numbers as any. I'll leave space for y. We're in quadrant 4, so here's 5. We have a length of 13. That's pretty long, so this is going to be maybe down here. And then our y-coordinate will be something negative. Let's see what that is. We can solve it numerically, or we can use the fact that this right triangle is a common Pythagorean triple. And so our y-coordinate must be negative 12. So here are the trig functions. Cosine was given to us, but for the sake of the framework, I'm just going to copy it. Again, the reciprocal functions are just the reciprocals, obviously. The final example has a bit of a twist. We know that y over x is negative 1/3. X and y are both coordinates, and so do we let y equal 1 and x equal negative 3, or do we let y equal negative 1 and x equal positive 3? Either one would yield a tangent of negative 1/3. We look to the other piece of information to resolve this. We're in quadrant 2. So when we sketch this, we see that x must be negative because we're in quadrant 2. That's the only way to get to quadrant 2. And y will be positive 1. Now we just need to find r. Now we have x, y, and r. We can simply fill in the trig functions. Again, remember, if radicals are involved, find the reciprocal of the version that already has the radical in the denominator. So when we flip it, we don't have any extra rationalization to do. Cotangent will be negative 3. Uh, Please remember that it's not fully simplified if you write negative 3 over 1. And that's it. Thanks for watching.